If the universe decided to delete itself right now, how much warning would you get? Tonight, when you look at the stars from a dark spot away from city lights, everything feels peaceful, ancient, permanent. But look closer. Every star, every planet, every atom around you is following the same invisible rules. We usually imagine the end of the world as something coming toward us, an asteroid, a black hole, the sun expanding, something out there. But what if the biggest threat isn't an object at all? What if it comes from inside the universe itself? And here's the question I want you to remember. If reality could suddenly change, would you see it coming? Imagine a ball sitting inside a small dip on the side of a hill. It isn't moving. Wind can blow past it, rain can fall on it, years can pass, nothing happens. From where you're standing, the ball looks completely stable. Now pull the camera back. Farther down the hill is a much deeper valley. The ball isn't at the bottom, it's simply trapped in the first dip. There is a lower place it could reach, but a hill stands between them. That simple picture is the key to this entire story. In physics, a state that looks stable, even though a lower energy state may exist, is called a false vacuum. The deeper, lower energy state is called the true vacuum. So imagine the universe as that ball. For billions of years, it has been sitting quietly in its valley. Galaxies form, stars burn, planets cool, life appears. Everything looks normal. But now comes the first open question. If the universe is not in the deepest valley, how could it ever get there? Normally, the ball would have to climb over the hill. That takes energy. But nature has another trick. At extremely small scales, quantum physics allows something very strange: quantum tunneling. Instead of slowly climbing over a barrier, a quantum system can sometimes cross it. Picture the ball disappearing from the shallow dip and appearing on the other side of the hill. No ramp, no explosion, just a sudden change in where it is allowed to be. If a similar transition could happen to a field filling the universe, one tiny region of space could suddenly move into a lower energy state. A tiny patch would be different from the space around it, and that patch is where the story gets much bigger. One field matters especially here: the Higgs field. Don't picture it as a glowing cloud. Picture an invisible landscape spread through every room, every planet, and every empty patch of space. You cannot see it, but it is there. Some fundamental particles interact with this field, and that interaction gives them mass. The Higgs boson is a tiny ripple in the larger field. Scientists detected that ripple in 2012, giving us direct evidence that the field exists. Now bring the hill analogy back. Imagine that invisible Higgs landscape has a shallow dip and, somewhere below it, a deeper valley. The important question is simple. Where are we sitting? Scientists cannot look at the universe and point to a hidden sign saying false vacuum. They have to infer its behavior from measurements. When the measured Higgs mass, top quark mass, and other quantities are placed into standard model calculations, the result is compatible with the possibility that our vacuum is metastable. Metastable sounds complicated, but the idea is simple. Stable for an incredibly long time without necessarily being the absolute lowest state. Think about a glass resting on a table. It can sit there for years. That doesn't prove it can never break. The same word is used in physics for a system that can remain settled for a very long time while a lower energy state may still exist. This is where we need to be careful. The calculations do not prove that the universe will collapse. They do not give us a countdown. They tell us that, within the standard model and current measurements, metastability is a possible picture of our vacuum. Now, imagine the thing that could start it. Somewhere in deep space, a tiny region changes state. At first, the bubble is microscopic, almost nothing to see. Then freeze the frame. The bubble has one side facing the old vacuum and one side containing the new state. It is not a normal bubble like soap. It is a boundary between two different states of the fields that fill space. Now, press play. The boundary moves outward. The bubble grows, and if vacuum decay happened, the boundary could approach the speed of light. This is where our opening question finally starts to close. Imagine a bubble forming billions of light years away. You are standing outside at night. The stars look unchanged. Nothing flashes. No alarm appears on your phone. No telescope suddenly shows a wall coming toward you. You can't watch the bubble chase you across the sky because information cannot reach you before the event itself. The first signal that could tell you the bubble is coming would arrive with the bubble. So the warning time is not minutes, not seconds. In the idealized picture, there may be no advance warning at all. But now ask the next question. What is actually inside the bubble? Don't imagine a giant fireball. Imagine a normal atom on screen. Electrons around a nucleus. Atoms connecting into molecules. Molecules building water, air, rock, cells, and everything you recognize. Now imagine the invisible background rules shifting underneath those particles. Inside a different vacuum state, fields could take different values. That could change the properties of fundamental particles and the way matter behaves. The chemistry around you only works because the laws and constants of physics have the values they do. Change the underlying conditions enough, and ordinary atoms may no longer form or remain stable in the same way. So the frightening part is not that a wave of fire destroys Earth. It is stranger than that. The universe could stop being the kind of place where Earth, chemistry, and familiar matter can exist. And there is another open loop. If such a transition is possible, could one have happened already? Pull the camera away from Earth. The planet becomes a dot. Keep going. The solar system disappears into the Milky Way. Keep going. Galaxies fill the screen. Now imagine, somewhere beyond our observable horizon, a tiny bubble appearing billions of years ago. It grows while the universe keeps aging. Galaxies vanish behind it. We would never know, because their light would never reach us from the future of their destruction. To us, the universe could still look peaceful, and if a bubble were actually moving toward us, there would be no countdown clock, no bunker plan, no spaceship that simply outruns light, just the quiet sky, until the moment the new state arrived. For most of human history, vacuum decay was a theoretical possibility with no direct experimental clue tying it to our universe. The 2012 Higgs boson discovery gave physicists a much better handle on one of the measurements that enters the calculation. The top quark matters too, and so does the strength of the strong interaction. Put those numbers into the equations, and the result lands in an interesting region between absolute stability and metastability. Not a knife edge, not a deadline, a possibility. And that distinction matters. If the vacuum is metastable, its lifetime could still be vastly longer than the current 13-8 billion year age of the universe. The equations do not tell us that the collapse is coming tomorrow. They tell us that the universe may not be in the final state it could occupy. So, what can we do about it? Absolutely nothing. And strangely, that may be the comforting part. We spend our lives worrying about things we can influence: school, money, deadlines, plans for next week. We build routines because routines give us a sense of control. Vacuum decay is different. If it happened, there is no practical preparation that guarantees survival, and there may be no warning to prepare for anyway. But that doesn't mean you should spend tonight staring at the sky, waiting for it. The universe could remain stable for an unimaginably long time. It may never undergo vacuum decay at all. Until something changes, the stars are still burning. The Earth is still turning. Your room is still exactly where you left it. Every ordinary Tuesday is still happening. Every cup of coffee still gets cold. Every frustrating commute still ends. Every conversation, every laugh, every quiet moment is happening inside this strange pocket of stability. Remember the ball from the beginning? For now, it is still sitting in the valley. Maybe that is the strange comfort hidden inside vacuum decay. Not that the universe might disappear, but that we are here while it is still here. The universe is running. The stars are still above you, and for now, the view is still beautiful. We are just enjoying the view from the false vacuum.